Today I would like to explain section 11.2. Section 11.2 begins on page 789. The equations we're learning on this section are summarized on page 792 at the bottom. You'll notice on the bottom of page 792 there are 4 diagrams. The first 2 we've learned about already. First was the area of a parallelogram. We learned that the area of a parallelogram is the base multiplied by the height, which is perpendicular to it. A equals B times H. The second equation we learned was the equation of the area of a triangle. We learned that the area of a triangle is half of the base times the height. Today we're going to first learn about the area of a trapezoid and then learn about the area of a rhombus/kite. The rhombi and the kite both have the same formula for area. So let's begin with the area of a trapezoid. The area of a trapezoid is right here, mentioned for you in my notes as the height multiplied by the average of the bases. If you take base 1 and add to that the length of base 2 and divide by 2, you'll have the average of the bases. And if you multiply that by the height, which is perpendicular to the bases, you'll be able to find the area of a trapezoid. By the way, let's just review a minute. What is a trapezoid? A trapezoid is a 4-sided figure in which one pair of sides are parallel. So notice I have here in the diagram an arrow here and here. The top is parallel to the bottom, but the left and right are not parallel. So a 4-sided figure in which one pair of sides are parallel, the other are not. So as I've mentioned in my notes here, the area of the trapezoid is the average of the bases multiplied by the height. I'd like to look at a few examples for you. I'd like to look at example number 1 on page 793. Notice on this picture, the bottom base is 6 units long. The top base is 16 units long. If I average those, I take 16 plus 6, I divide by 2, I multiply by the height, which is perpendicular to the bases, and I will be able to find the area. On problem number 5, they give me the area is 78. I have to solve for the height. So what I'm going to do is I'm going to add the 2 bases together, the 6.4 and the 13. I'm going to divide by 2. And once I get that number, I'll divide 78 by that number, and that will be the height of the trapezoid. Very straightforward. Area of a trapezoid is the average of the bases multiplied by the height. The last formula for today is how to find the area of a rhombus or rhombi and a kite. This formula says I'm simply going to take the product of the diameters and multiply by 2. So I've pictured here a blue kite, and I've also used dotted lines to show you that actually a kite is going to be 1/2 of a rectangle. So that's why you're basically taking the width times the height and dividing by 2. If you just did width times height, you'd have the area of the rectangle, but the kite is 1/2 of that. So diagonal 1 times diagonal 2, divide by 2. I'd like to look at a few examples. Example number 2. I notice in my textbook on page 793 at the top, the width of the trapezoid is 18. The height of the trapezoid is 10. If I take 18 times 10, which is the product of the 2 diagonals, and divide by 2, I will have the area. One more example, example number 6. They gave me the area is 96. 96 is equal to the product of the 2 diagonals. One of the diagonals is pictured with just a half, so half is x. 2 of those would be 2x. But to multiply 2x by 7.3 plus 7.3, which is 14.6. So the product of the total diagonals, 2x times 14.6 divided by 2 is 96. And I think you know how to solve this. We're going to multiply both sides by 2 and then divide both sides by 2 and 14.6. Or in other words, divide both sides by 14.6. Your assignment for today is page 793 and 794, problems 1 through 22. Thank you.